My name is Kainton the Genius, and today we are going to be talking about consistent statistic. I'm going to explain this concept in a very clear, brief, and simple way. So, consistent statistic is simply a way to describe a estimate that is made such that as the number of sample increases, this estimate converges to the actual parameter. Let me demonstrate. So let's say we have a population of items. And in population, we always talk about parameter. A parameter is simply a property of a population that we want to measure. And now we are taking out a sample from this population. So we are taking out a small sample. So in this case, we are talking about statistic. So any measurement we take about the sample is called a statistic, and measurement about or properties of the population is called a parameter. So if we are talking about, let's say, the mean of a population, the mean is represented in this way. So it's a parameter that we may like to estimate because it's not possible for us to estimate or to calculate the mean of a population by summing all the items in a population. That is not possible. So what we can do is to take out some items from this population and calculate the mean. And we are hoping that the mean we calculated from this sample will be equal to the mean of the population. Now, if we calculate a mean from this sample, we'll have this is the mean of the sample. So is this mean equal to this one? That is the problem. If this mean is consistent, the one we calculated from the sample, then as n increases, where n is equal to number of items in our sample, or simply call it sample size. So as n increases, then this value, our estimated value tends towards the actual value. So let's illustrate. We want to do this estimate using a procedure in this way. We have x is equal to 1 over n minus 1 sigma I is equal to 1 to n x xi, okay? So xi simply means all the items in our sample. So what is xi? Xi is the expected value of an item taken from this population. Remember, we are taking item from this population and moving it into the sample. So if we are taking out item from this population, the expected value of the item in this population will be x bar. So the expected value of an item taken from the population xi is equal to 1 over n sigma I is equal to 1 to n expected value of xi, of the mean of the samples. So if we take out an item from this value, the expected value is going to be equal to the mean. So simply that if you have a list of items 2, 4, 5, 6, 3, 2, 1, 5, 4, so the expected value of any item taken from this place is equal to the mean of these items. All right. So expected value of items taken from this population is equal to the mean, is expected to be the mean of this population. So that is why we write it in this way. So that will be equivalent to, we have n minus 1, I've written here. So that will be equivalent to 1 over n minus 1. We are now counting all the items in our sample because we are taking one item at a time and we are taking n items. So it will be n times mu. We have collected n items and the expected value is mu. Now we can write this as n over n minus 1 times mu. So this is expected value of our sample mean. Expected value of this statistic is giving us 1 over n minus 1. So what we are saying is that this value here that we have should be equal to this, to be getting close to this, the parameter mu, as the value of n increases. And think of it, if n is equal to 10, n is equal to 100, n is equal to 1000, n is equal to 1 million. So the more the value of n increases, the more this value, this quantity n over n minus 1 tends to 1. And that means the more the quantity n over n minus 1 times mu tends to mu. And in that way, we can say that this statistic that we've calculated from this sample is consistent statistic. So compare this with the definition we have here that says what is consistent statistic is a statistic such that as n increases, the estimated value converges to the actual value of the parameter. And we have succeeded in proving it in this place. So I'm going to stop here and I'd like to thank you for viewing. Remember, subscribe to my channel. And also, if you have some questions, please leave it in the comment box below. I remain kind on the genius, and I'm always here to help you solve problems in statistics and computer programming.